Okay. Hello everyone. Once again, today we are going to discuss about the new topic which is related for the 10th class. And today I brought some keywords regarding the upcoming exam, because within a few days the 10th class students will going to face the board exams. So I brought some key point on the science subject. Let us, as you know, every day from morning to evening we are going to consume lot of the things in the form of a food. Yeah, we see the different type of or the different items that we are going to eat, we are going to consume. They are differ from each other. Some food items are sour in the taste, some items are sweet in the taste, some items are salty in the taste, and some items are having different nature, different properties. Today we are going to discuss about these points which are known as that is the acid, base and the salt. That is the chapter 2 from the 10th class. Okay, let's begin this class. First of all, we are going to see what are the acids. Acids are the substances that form hydrogen ions when dissolved in the water. It means the acid, when we are going to mix with water or when acids are dissolved in the water, they give up hydrogen ions. We know there are the different type of the acids. One is the hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, acetic acid, citric acid, phosphoric acid, and the oxalic acid. There are the many types of acids we see. If we see the physical properties of the acid, first point, the acid taste sours. For example, we take the vinegar, lemon juice. When you are going to drink the lemon juice, you come to know the taste of the lemon juice, that is sour in the taste. Second thing is important, that is the acid are harmful to living cell. For example, which acids are very harmful to the cells here? One is the hydrochloric acid when it is concentrated, sulfuric acid, H2SO4. Here I am not going to take the molecular name, just I am going to use the formulas. Okay? Why? Because we have to write the formulas in the test. We have to identify the formulas of the chemicals. And next one is the HNO3, that is the nitric acid. These three acids are very dangerous for the living beings or the living cells. When they fall on our body or on the cell, it start to kill the cell or it start to damage the cell. Some of the acids are we are using our kitchens while in the cooking. Some acids are already present in the foods, for example, lemon. Okay. Some acids are harmful to living cells. And third point is the aqueous solution of all acid contains hydrogen ions. It means when acid is in aqueous solution, we call it as in the liquid solution, contain hydrogen ions. Acid turns blue litmus paper into red color. You know that in the litmus paper experiment, we are going to check the acidic and the basic properties of the substances by using the litmus paper. Here, when we are going to put the blue litmus paper on the acid, it turns into the red. It means it indicates the substances which we are handling, that is the acidic. Next point is strong acid or corrosive. These are the physical properties of a acid. we must remember these properties of the acid. Okay, in the exam they can ask, write some physical properties of a acid, then we are going to point out these all the things or these all the points, then we will score the good marks. And remember that the molecular formula of the acids, hydrochloric acid, the molecular formula is HCl, sulfuric acid formula is H2SO4, nitric acid formula is HNO3, and the carbonic acid formula is H2CO3. These are the molecular formula of what do we call? These are the molecular formula of the acids. You can check on the slide here. If we move further, the second point of this chapter is bases. What are the bases? Bases are the substances that forms hydroxide OH group. In the acid, they liberate or they produce H ions or the H ions we can say. But in the bases, the substances forms the hydroxide ion, that is the OH minus ion, when dissolves in water. It means we take the base and we are going to mix with the water. When we mix the base with the water, it produces OH ions or the hydroxide ions. The physical properties of bases are they taste bitter. Strong bases are corrosive, as acid is corrosive. The strong bases are also corrosive. In the aqueous solution, of all bases contain hydroxide ions. If we see the acid, when it was in the aqueous solution, when it is in the aqueous solution, it produces hydrogen ions, but when the bases are in aqueous solution, they produce hydroxide ions. And bases turns red litmus paper into blue color. When we conduct the litmus paper experiment, the red litmus paper is converted into blue. Red litmus paper converted into blue. And next point or the next properties of the bases is the Sophian slippery into touch. When we are going to touch the base, it slippery in a touch. It slides in our fingers. And the bases are, here we can see the NaOH, sodium hydroxide, ammonium hydroxide, calcium hydroxide. These are Na4OH, NaOH2, NaOH. These are the bases. Okay. Next, in this chapter there is an important point that is known as the indicator. We see the different type of indicators. Okay. Litmus paper, turmeric, red cabbage, and colored petal of some flowers like the petunia, hydrangea, and geranium are the natural indicators. Turmeric, this is very familiar to us, so we are going to take the example as the turmeric. Turmeric is an indicator. Methyl orange and phenolphthalein are synthetic indicator. It means they can prepared. The prepared indicator, we can say that methyl orange, phenolphthalein. The spelling of this word, if we see, it confuses us. We are going to pronounce it as the phenolphthalein. Phthalein. That HTH will become silent here. Okay. The substances whose odor changes in acidic or the basic media, such indicators are called olfactory indicator. It means the substances which changes the odors in acidic or the basic medium, they are known as the olfactory indicators. For example, vanilla or the onion or the clove. These are olfactory indicator. Remember, he can ask you in one word or one sentence or MCQ question. find the olfactory indicator. He can give the options in that is the vanilla or onion or the cloves. Okay. In the picture we see the lead litmus paper and the blue litmus paper, which we are going to use to identify whether the substances is acidic or basic. If we come to the chemical properties of acids and the bases, this is a very important point of this chapter. That is the reaction of acid with metal. When acid is reacted with metal, what will happen? What are the products? Let us see here. The acid, when react with metal, they use out salt and hydrogen gas. Remember, when any acid, when it is react with the metal, it gives a salt and hydrogen gas. For example, HCl plus Zn. HCl means that is the hydrochloric acid. Zn means zinc. When they react with each other, they give out the salt. The salt is nothing but zinc chloride, ZnCl2, and it liberates the hydrogen gas. Same, if we see the reaction of the bases with metal, that it gives out same thing here, NaOH plus Zn. It gives out Na2ZnO2, that is sodium zincate, and produce the hydrogen gas. These are the chemical properties of acid and base. Okay. Next, how do metal carbonate and metal hydrogen carbonate react with acid? Let us discuss one by one here. First one. It means metal carbonate and metal hydrogen carbonate react with acid. Look here, Na2CO3, when it combines with or when it is reacted with HCl, that is the hydrochloric acid, that gives out NaCl, that is sodium chloride plus water plus carbon dioxide. That is sodium carbonate. Yeah? Sodium carbonate react with hydrochloric acid. It gives out NaCl plus H2O plus CO2. Next one, NaHCO3, when combines with HCl or when reacts with HCl, it gives out NaCl plus H2O plus CO2. That is the sodium hydrogen carbonate. First one is the carbonate, sodium carbonate. Second reaction, sodium hydrogen carbonate. It means first reaction shows us when sodium carbonate react with hydrochloric acid, it gives the sodium chloride plus water plus carbon dioxide. In the second reaction, when the sodium hydrogen carbonate, sodium Na, hydrogen H, carbonate CO3, this is known as the sodium hydrogen carbonate, react with HCl, that is the hydrochloric acid, gives out NaCl plus H2O plus CO2. Here we see the explanation or the definition. In the above reaction, acid react with the metal carbonate and the metal hydrogen carbonate to gives out salt and carbon dioxide and water. If you come to the first reaction, you see that the sodium carbonate react with hydrochloric acid, give out a salt, that is NaCl, and gives out carbon dioxide, that is CO2. In next one is the H2O, that is the water. It means whenever the metal carbonate react with acids, they use out salt, carbon dioxide and water. Just to remember this definition, you are going to write the equation. You have to just remember all the, or you have to memorize all the molecular formula of chemicals. Limestone, chalk and marbles are the different form of calcium carbonate. These are the different forms of calcium carbonate. If we ask the another form of calcium carbonate, you can write the limestone, chalk or marbles. These are the different forms of calcium carbonate. Sometimes he will give the reactant. Reactant means the left hand side. Your left hand side, the chemicals are known as reactant. On your right hand side, chemicals are known as a product. Remember that. For example, Na2CO3 plus HCl is a reactant and NaCl plus H2O plus CO2 are product of that reactions. Okay. Next point, the reaction between acid and bases. We are going to make the reaction between each other, acid and bases. See here picture, when acid combines with the bases or when acid react with the bases, they give out salt and water. See in this picture, on your right hand side, there are the two beakers, which one is contain the acid, another one contain the base. Then we are going to react, make them to react with each other. They give out salt and water. In the example, we can see here NaOH plus HCl. NaOH is a base, HCl is the acid, sodium hydroxide. That is NaOH react with HCl, that is the acid, gives out NaCl, that is the salt, plus water, that is H2O. Whenever the acid react with base, it gives out salt and the water. The reaction between a acid and base gives or give a salt and water is known as a neutralization reaction. He can ask you the definition in the exam. This video will help for both classes, 8th as well as 10th class. The 9th class student, they can learn before your academic year start. And the 10th class student, they can point out these definitions, these explanations in your notebook. These are help you in exam. You can take it as a keywords or the key points to study. If we ask what is the neutralization reaction, then you have to write the reaction between the acid and the base to give a salt and water is known as a neutralization reaction. For example, NaOH plus HCl gives out NaCl plus H2O. That is neutralization reaction. Whenever you see when the acid react with the base, they give out the salt and the water, that is nothing but the neutralization reaction. Okay. Next point, if we come to here, the point is reaction with metallic oxide. In the reaction, metallic oxide react with the acid to give out salt and water. Means here also the same product will come out. If you see the before this slide, here when acid and base react with each other, they will give salt and water. When the metallic oxide react with each other, metallic oxide react with the acid, they too give out salt and water. Then what is the difference between here? Means the metallic oxides are said to basic oxide. It means metallic oxides are basic oxides. Are you getting my point? In the reaction, metallic oxide react with acid to give out salt and water. Here metallic oxides are basic oxides. Reaction of a non-metallic oxide with bases. If we see non-metallic oxide react with the base, what are the products here? If we see here, non-metallic oxide react with a base, give out salt and water. These also produce as a product salt and water. And non-metallic oxide are said to be acidic. Metallic, you can see the difference between the metallic oxide and the non-metallic oxide. Okay, when metallic oxide react with acid, they give out salt and water. Remember, once again I will repeat here, metallic oxide react with acid, give out salt and water, and metallic oxides are said to be basic oxide. If we come to the non-metallic oxide, when they react with the base, they give out salt and water, but non-metallic oxides are said to be acidic oxide. Metallic oxide are basic and non-metallic oxides are acidic. This is the difference between the metallic oxide reaction and the non-metallic oxide reaction with the acid as well as base here. I hope you are getting my point. This is a very important point. Note down this point, it will help you in the exam. Not as a copy, you have to memorize them. Okay, let us see the next point. What happened to an acid or a base in water solution? Then we are going to combine the acid or the base with water solution. What will happen here? Acid react with water, give hydronium or the hydrogen ions. Hydronium means hydrogen ions. H3O plus ions or H plus ions in the water. Whenever you are going to add acid with water, they produce hydrogen ions. Remember this point. Okay? Second point, if you see, the bases react with water to give hydroxide OH minus ion. When acid react with water, they produce hydrogen ions or H3O ions. When a base react with water, it gives out a hydroxide, that is OH minus ion. Bases which are soluble in water are called alkalis. Remember, bases which dissolves in water, which mix with water, they are known as alkalis. Means the reaction with acid or a base with water is highly exothermic. Exothermic means, I hope you remember, recall your memory, recall the previous classes knowledge. Exothermic reaction. Exothermic reaction means in the reaction where heat is liberated. This is also the exothermic reaction when acid or base react with water. It is highly exothermic reaction. It means when the acid or base react with water, they release the heat, they liberate the heat. When in the reaction, the heat is liberated, that is known as exothermic reaction, or this is also known as the exothermic. Because acid and base react with water, they liberate the heat. That is known as the exothermic. In some time, heat generated maybe cause the mixture to the slabs out and causes burn. It means sometime it will burns. It will break the container. If the excess heat is liberated while the experiment, they can break the test tubes or the reaction container. Splash out and cause burn. Or sometime what happen? It will liberate heavy heat. Because of that heat, the container may be break due to excessive heat liberated in the reaction. These are the important points. Note down. That is, when acid react with water, it liberates the hydrogen ion. When bases react with water, it liberates the OH ion. Some bases are soluble in water. They are known as alkalis. These are the means the reaction of acid and base with water, that is the exothermic. Okay. Let us see the pH scale. Before start the pH scale, we have to see the abbreviation of the pH. That is, the pH means the potential of hydrogen. Potential of hydrogen. Potential means that is the concentration power. Potential means the stored power of hydrogen, we can say here. Remember that the long form of the pH is the potential of hydrogen. In a scale or is a scale used to measure the hydrogen ion concentration in a solution. It means this is a scale where we measure the concentration of a hydrogen in the solution. If we take the solution, if we put a pH scale in that, it shows the concentration level of a hydrogen ions. If we see the pH, the P is stands for potentia. In the German language, it is known as the power. Power of a hydrogen. Potentia of a hydrogen. Second point, the P in the pH stands for potentia. In German or in the German language, potentia means power. Here we see the power of hydrogen ions in the solution. You see here the third point, that the higher hydronium ions or the hydrogen ions concentration are lower in the pH value. If we are measure, it helps us to measure the value or the level of the concentration of a hydrogen ion in the given solution. We are analyze here the below point. We are going to take the range of a pH scale, or we are going to analyze the pH scale from 0 to 6. In the picture on your right hand side, below the sentence, you can see the pH scale from 0 to 6. It is known as acidic. 0, 1, 2, 3, 4, 5 and 6. Up to this, from 0 to 6, you can see that this is the acidic. Here you can see some symbols or some picture on pH scale. That is the gastric acid, lemon juice, apple juice, tomato juice, and the black coffee and milk. These all items come in acidic level. On pH scale, we see these all things come in the range of acidic. In 7 is the neutral, not a base, nor a acid. That is the neutral, that is the pure water. If we see the next point, 8 to 14 is alkaline or the basic. 8 to 14. 8, 9, 10, 11, 12, 13, 14. These all are alkaline basic. Okay, that you can take the example egg, baking soda, and hand washing soap or hand washing, whatever you take that in the form of liquid or in the form of a soap. And some are that ammonia, what is that solution, that is the bleaching powder. These all are come in the basic. We can indicate the acidic and the basic properties of a acid with the help of colors present on pH scale. Means the pH paper changes color to indicate a pH value here. If you take the pH scale, if you put it in the solution, then take the scale outside from the solution, it changes the colors. If we tally the changed color to the pH scale, we can indicate, we can identify whether the substances is the pH or whether the substances is a acid or a base here. Okay, I hope you people are getting my point. Next one, the strength of acid and base. We see the how strong are acid and how strong are base. If we see our in the blue pattern or in the blue section, that is related to the acid. If you see in the white section, that is related to the bases. In the left hand side we see the acids, that is the acid that give rise to more hydronium or the hydrogen ions are said to be strong acid. It means when the acid gives rise to or when acid liberate the hydrogen ions, they are said to be the strong acid. If you compare to the base that give rise to the more hydroxide ions, that is OH minus ions, are said to be the strong base. When the substances liberate the hydrogen ion, that is the acid. When the substances liberate the hydroxide ions, that are the strong bases. Remember the simple tricks. The second point, acid that give rise to less hydronium or hydrogen ions are said to be weak acid. The substances which liberate less hydrogen ions, they are known as a weak acid. The base that which give rise to or which liberate the less hydroxide ions, they are said to be weak base. Very simply we can remember them. If the acid liberate the high hydrogen ions, they are strong acid. If the base liberate high level of or the high hydroxide ions, they are the strong base. If the acid liberate low amount of the hydrogen ions, that is known as the weak acid. If the base liberate less amount of OH minus ions or the hydroxide ions, they are known as the weak base. Maybe in the question paper, he can ask the definition of a strong acid, strong base, weak acid, weak base. If you compare these questions with the previous question paper of the 10th class, you come to know that what type of question he will ask on the acid, base and salt. Regarding acid, base and the salt, you have to compare these points with the previous question paper. I suggest you all of you, please refer previous question paper of 2 to 3 years. It will help you to solve the questions of a present or upcoming question paper. Okay. Next point, the importance of the pH in the life. Our body, first point, our body works within the pH of 7 to 7.8. Our body, this is the human body or your body, which works between 7 to 7.8 of a pH scale. Not more, not less. It have to work from 7 to 7.8. If it work on above 7.8, that is abnormality cause. It causes the abnormality. If our body start to work below 7, it is also abnormality. Okay? When pH of rain is less than 5.6, it is called acidic rain. Now that in the June, rainy season will start. If you collect that rainy water and you measure the pH of the rainy water, if the pH of that rain water is less than 5.6, then that rain is acidic rain. Remember this. Third point, our stomach produces hydrochloric acid which help in the digestion. Whenever we consume the food, our stomach start to release the hydrochloric acid which help us to digest our food, and it is not harm our stomach or the stomach layer or the stomach, the cell present in the stomach. Without harming our stomach, hydrochloric acid help us to digest our food, whatever you consume, in 3 times. Next point, in case of indigestion or our stomach produce more acid and this causes pain and irritation. Whenever there is a problem in digestion, our stomach start to release more acid that we call as a acidity. Sometimes we feel that is our chest is burning, our stomach is burning. Why? Because of more hydrochloric acid is liberated in our body. Because of that, it seems to pain or the irritation in the chest. To get rid of this problem, if we have to come out from this acidic problem, we are going to use the bases as an anti-acid or the antacid. These antacid neutralize the excess acid which is produced in our body. It means the bases reduce the acidity in our body and neutralize. Before we saw that when acid and base combined with each other, it is known as neutralization. It means whenever the acidity is increased in our body, we are going to consume the bases in the form of the antacid or the anti-acid that neutralize the acidity in our body. You can take it as a, what you call that, ENO. That is anti-acid. Magnesium hydroxide, just we saw the pH scale. Magnesium hydroxide, milk of magnesia, is a mild base. We saw the pH scale from 8 to 14 is known as a bases. Here the milk come in the scale of bases. The tooth decay start when the mouth pH is lower than 5.5. Means teeth. Our teeth start to decay when the pH of our teeth decreases below 5.5. Because our tooth contain calcium phosphate. Because next one is there, the tooth enamel is made up of calcium phosphate. It means our tooth made up of, our teeth are made up of calcium phosphate, which is the hardest substances in our body. It's our hardest substances present in our body. If the pH of this calcium phosphate decrease below 5.5, then tooth start to decay. After that, you have to put the silver teeth like me. If the pH of the value decreases below 5.5, remember. Then the toothpaste which are basic in nature. The toothpaste which we bring from the market, that may be the Colgate, Pepsodent, Close-Up, Miswak, whatever you bring, that are in the basic nature, neutralize the acid and prevent our tooth decay. It means if the acidic property is increased in our teeth, then the toothpaste decrease that acidic property and it's protect our teeth to decay. Okay? Next one. There are some acid and there are some substances. Acetic acid is present in the pineapple. Citric acid present in the lemon and orange. Tartaric acid present in the tamarind and the grapes. Ascorbic acid, that is vitamin C, is known as the ascorbic acid, that present in all the citric fruits. The fruits whatever contain the citric juice, they are come in the vitamin C. Next one is the lactic acid, which is present in milk and the yogurt. Malic acid present in apple and pears. Formic acid present in intestine. Formic acid means the red ant. Whenever the red ant bite us, we feel the burning sensation because of formic acid. Means the red ant contain the formic acid as a weapon in their body. Okay. Next one about the salt. Maybe this section will go longer because there are a lot of the point in this chapter. What is the salt? We are going to use the salt in our day-to-day life, isn't it? Whenever we eat the new substances, we are going to put some oil, and whenever we cook the food, we add the salt. Here, let us see the definition of the salt. A salt is an ionic compound that forms from positive ions from a base and negative ions from acid. Remember that the reason of formation of a salt is it takes the positive ions from the base and negative ion from the acid. For example, see the below reaction. HCl plus NaOH forms the water plus salt, or NaCl, H2O plus NaCl. It means from the above definition, if we compare this reaction, the positive ions from a base. Positive ions means, which one is here? NaOH is the base, OH is the ion here, right? Or you can take it as a Na. Sorry, Na is the ion here, that is the sodium, and it take the negative ions from acid, that is Cl. Cl, chlorine have negative ions, and the in the NaOH, Na means sodium having the positive ions. NaCl combined with each other to form NaCl. Once again I repeat here the equation and the definition. Carefully listen. The positive ions took from the base, that is the Na. Na means sodium, which contains the positive ion, and negative ion from acid, that is HCl. Cl contains, chlorine contains the negative ions. Then the formation is H2O, that is the H2O, that is the water, and form the NaCl, that is salt. I hope you people are understood this one point. Let us see the definition about this only. The combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. Nothing but a salt which we use in our day-to-day life. The combination of the hydrochloric acid means HCl with sodium chloride solution, NaOH. It is known as sodium chloride, or it forms known as the sodium chloride, that is the NaCl. That is nothing but a salt which we use in our day-to-day life. I hope you people enjoy this class. Second thing, from the common salt, there are the many raw materials or the raw chemicals come out here. That is the raw material for chemicals from the common salt. The common salt obtained is an important raw material for the various material of a day-to-day uses. It means the common salt or the salt is used for many chemical substances. To prepare the many chemical substances, the salt is work as a raw material. Which are the substances we use in our day-to-day life? Let us see what are those. Such as sodium hydroxide. What is that? Sodium hydroxide. Just recall, just I told you before. Next one is the baking soda. Next one is the washing soda. Next one is the bleaching powder. And some many more substances. Common salt is the raw product for these substances. These substances means sodium hydroxide, as a sodium hydroxide, baking soda, washing soda, bleaching powder. Let us see one by one. Okay? These raw material. In the first, we see the sodium hydroxide. Sodium hydroxide, when electricity is passes through an aqueous solution of sodium chloride, there is a diagram in your textbook. You can compare this explanation with that diagram which is present in our textbook. When electricity is passes through an aqueous solution of sodium hydroxide called barium, it decomposes to form the sodium hydroxide. The process is called as chlor-alkali process because of the product formed the chlor of chlorine and alkaline from the sodium hydroxide. It means there are the two products, one is the chlor and another one is the alkaline. Chlor is formed by chlorine, alkaline formed by the sodium hydroxide. If you see the below reaction, you come to know that NaCl combines with or react with H2O to form the NaOH. I am not going to count the molecules of the chemical, that is the 2H2O. That, for example, once again, NaCl combined with 2H2O to form 2NaOH plus Cl2. Cl2 means chlorine. Alkali means NaOH aqueous solution, and which liberate the hydrogen gas. On left hand side, you can take the sodium chloride. When the electricity is passed through the sodium chloride, it decomposes the sodium hydroxide, and this process is known as the chlor-alkali process. Why? Because the chlorine forms the chlor and sodium hydroxide form the alkali, that is known as the sodium hydroxide. Okay, carefully listen this and see these points to come to know how the sodium hydroxide is formed. Second one is the bleaching powder. It is formed by, directly I come to the definition, it is formed by an action of a chlorine gas on a dry slacked lime. It means bleaching powder is prepared by the action of a chlorine gas on dry slacked lime. The molecular formula of bleaching powder is CaOCl2. And the uses of the bleaching powder, first point if we see, the bleaching cotton and nylon in textile industries. To bleach the cotton, to bleach the linen cloth in textile industries, bleaching powder is used. And bleaching powder is used to wood pulp paper factory. It is used in the paper factory also. And bleaching washed cloth in laundries. We give our clothes to laundry to wash. They use the bleaching powder to clean our clothes here. The next point, bleaching powder is an oxidant agent in many chemical industries. It means bleaching powder is used as an oxidizing agent. And the last use of the bleaching powder is to make drinking water free from germs. We can kill the germs by using the bleaching powder. Next point, that is the baking powder. It is produced by using sodium chloride. Means bleaching powder is prepared by using the sodium chloride. The chemical name of the sodium chloride, the chemical name of the compound is known as sodium hydrogen carbonate, that is NaHCO3. See the below reaction. NaCl combined with H2O plus carbon dioxide plus NH3, it gives out NH4Cl plus NaHCO3. NaHCO3 is nothing but sodium hydrogen carbonate. Sodium chloride combined with water plus carbon dioxide plus ammonia to give out the NH4Cl plus sodium hydrogen carbonate. And the uses of the baking powder is, it is used in soda acid fire extinguisher. It means baking powder is used in the fire extinguisher to off the fire or to cut the oxygen from fire. Next point, it is also an ingredient in antacid. It is used in antacid, which decrease the acidic property in our body. It means it is the ingredient of bases, which baking powder. Next use is for making the baking powder itself. Okay. Next point, the preparation here. Let us see. Same thing again here. A mixture of baking soda along with the mild edible acid such as the tartaric acid, when baking powder is heated or mixed with the water, carbon dioxide is produced, which causes the bread cake to rise, making them soft and spongy. This is used in the bakery also to make the bread and cakes spongy. You can see the below reaction, same it is in the before. NaHCO3 and combined with the hydrogen ions, it gives the carbon dioxide plus water and the sodium salt of acid. And this is baking soda is used in the what you call the bakeries also to prepare the bread and the cake in the form of a sponge. Okay. Let us move for the next point. That is the same. This is the baking soda preparation. Same thing it is used here. Alkali neutralizer for baking soda is used as a neutralizer, used in the for a fire extinguisher. and it is used in the to reduce the antacid. It is the gradient of antacid. Okay. Next point, washing soda, Nirma. Let us see this. The chemical name of washing soda is known as the sodium carbonate. That is Na2CO3, 10 molecules of water. That is the chemical name of washing soda is sodium carbonate. Recrystallization of a sodium carbonate gives washing soda. It means recrystallization of a sodium carbonate. If we recrystallize the sodium carbonate, it gives the washing soda. It is a basic salt. Which one? That is, washing soda is a basic salt. And the uses of the washing soda is used in the glass, soap and paper industries. In the preparation of a glass, in the preparation of soap, in the preparation of paper, the washing soda is used. Using in the manufacture of a sodium compound such as broths. In the preparation of a broths, the washing soda is used. Used as a cleaning agent for the domestic purpose. In your home, your mother is using the detergents or the washing powders. That is nothing but sodium carbonate. Used for removing the permanent hardness of water. The washing soda is used. Next one. Just imagine that what the salt which you used in your day-to-day life, are they really dry? Is there any water molecule present in the salt? Let us see here whether they are dry or not. Copper sulfate crystals, when heated, lose water and turns from blue to white. When copper sulfate crystals, when heated, copper sulfate crystals lose the water. It means they liberate the water and it turns from blue to white. Next point, water of crystallization is the fixed number of water molecules present in one formula unit of a salt. Third point, the chemical formula of a hydrate copper sulfate is CuSO4.5 water molecules, 5H2O. You can take it. Next one, gypsum chemical formula is CaSO4, 2 molecules of water or 2H2O. Remember that I prepared this slide in the form of the keywords, key points. It will help for the 10th as well as the 9th student. Just they come to the 10th class, they can get the use. And this is very helpful for all competitive exams. Why? Because every competitive exam there are questions. The questions are present related to the science here. Maybe in the competitive exam they can ask the formula of gypsums. They may be asked the copper sulfate molecular formula. So it will help for the high school student as well as all the competitive exam. Please get this point. Okay. Next point, plaster of Paris. You are very familiar to us. Why? Because the student, we are the student or the we are boys. Whenever we play, we fell down. We get fracture in our hand and leg. When we go to the hospital, the doctor suggests us to keep the plaster on your hand or the injured part. The plaster is nothing but that is the plaster of Paris. We use this plaster of Paris to decorate our houses, our homes. In the ceilings of our homes, we make many designs. with the help of plaster of Paris. And we see lot of these statues kept in our homes, like the dolls, toys. They are prepared by the plaster of Paris. First we see the plaster. What is the plaster of Paris? Plaster of Paris, on heating gypsum at 373 Kelvin, it loses water molecules and become the calcium sulfate hemihydrate. Look here, once again I repeat here, when the plaster of Paris heated gypsum at 373 degrees Celsius, it loses the water molecules. It means the plaster of Paris loses the water molecules and become the calcium sulfate hemihydrate. The molecular formula of this is CaSO4, 1 by 2 of water molecules, 1 by 2 H2O. This is called the plaster of Paris or the plaster of acid. I hope you people are getting my point. And the uses of the plaster of Paris is making the toys, materials for the decoration, just I told you before only. And second thing was for making the surface smooth. If you see the ceiling of our buildings or somewhere, whenever you visit for some extraordinary places, you see the ceiling are made with different designs with the help of a plaster of Paris. And doctor use for supporting the fractured bone in the right position by plaster of Paris. Okay. Thank you very much for listening my class. Please subscribe and like and share this video with your friends. Maybe they also get the help, and invite your friends to this channel to get more knowledge about the science and according to your classes. Why? Because in our YouTube channel we deal the classes from 5th class to 10th class. Only the science subject is dealt here. Okay, I hope you people will enjoy. Please ask everyone to subscribe and get the knowledge from this YouTube channel. Okay, thank you very much.